All right, so yesterday we talked about functions and in behavior. So today we're going to talk about how to sketch graphs. So yesterday we went from a graph and we had to describe the in behavior, and now we're doing the opposite. So now we're going to have an in behavior and we have to draw the graph from that. So we're going to have 3 examples. Let's go ahead and start with example 1. The directions: sketch the graph. Sketch the graph from the following features. Sketch the graph from the following features. So these are the features of the graph. First, the y-intercept is 2. The 0 is at 1. It is linear. Okay, and if x is less than -1, the graph is negative. If x is greater than -1, then the graph is positive. What that means is it's below or it's above the x-axis. And then we have the end behavior. So as x approaches negative infinity, the function is going to negative infinity. And as x approaches positive infinity, the function is going to positive infinity. So these are all of our clues, if you will, to help us graph this line or this shape or whatever it is. It is a line since it says it's linear. So I'm going to draw a graph, and I'm going to go to just 3 on each side. Okay, let's take the clues one at a time. First, it says the y-intercept is 2. So let's go up to 2 and graph a point. Then it says the 0, oh, oops, I'm so sorry. The 0 is at -1. Okay, so the 0 is at -1. So it crosses the x-axis at -1. It says it is linear. From -1 down, it's negative. From -1 up, it's positive. And let's check the in behavior. As we go to the left, the graph goes to negative infinity, and as we go to the right, the graph goes to positive infinity. So it works out. That is how we draw a graph from these little, what I like to call clues. So let's see if we can do a different shape. This is example 2, and I'm going to use a different shape. Same directions, just sketch the graph from these little clues. So first one, the y-intercept is 3. There are 2 zeros, one at 1 and one at -3. There is a relative max at -1, 4. A line of symmetry at x equals -1. And the in behavior, as x approaches negative infinity, the function is going to negative infinity. And as x approaches positive infinity, the function is going also to negative infinity. So it's going to be going down on both sides, left and right. Let's go ahead and make our graph. Since the max is at -1, 4, we at least have to go to 4. So I'm going to go 1, 2, 3, 4. And after we have our graph ready, we can use our clues. So I'm going to go in order, 1 clue at a time. Y-intercept is +3. So the y-intercept is right here, +3. If you want, as we go through them, you can kind of check them off. That way you know you did them already if you want. We have 2 zeros, 1 and -3. So here's 1, and here's -3. And check it off. The max is at -1, 4. -1, up 4. So you can kind of see the outline. See the outline there. There's a line of symmetry at x equals -1. So remember, line of symmetry is where we fold the graph in half and it looks the same on both sides. And here, their graphs will be going downwards. So we can kind of go ahead and make our shape. Just kind of follow the outline, and it checks all the boxes up. Boop, boop, boop. Checks them all up. So let's do one more. One more problem. Example 3. The clues are y-intercept at -3. The zeros are at -3 and +3. Line of symmetry at x equals 0. And the end behavior. As x approaches -infinity, the function is going to +infinity. And as x approaches +infinity, the function is going also to +infinity. So this means on the left it's going up, and on the right it's going up. Here's our graph. We're going to go to 3 on all sides. All right, let's use our hints, our clues. First, the y-intercept is at -3, so right there. The zeros are also at -3 and +3. There's a line of symmetry at x equals 0. So right down the middle is symmetry, and both of the end behaviors are going up. So, I'm just going to make some lines, make some curvy lines or straight lines. I'm just going to go with straight, and we have our third example. So let me know if you guys have any questions, and we'll see you